Okay, so we have finished chapter 3. The key concept in this chapter are framing, addressing, error control, flow control, and medium access control. And we have seen two dominant broadcast links, two dominant links, Ethernet and wireless LAN. And Ethernet is quite reliable, though it's simple, but it's still reliable. And wireless LAN is not that reliable. However, it provides mobility. And I don't know how many of you still use Ethernet now. I know in the dorm, mostly you are using Ethernet. However, outside the dorm, you probably use wireless LAN more often. Bridging, which is used to interconnect LANs, interconnect Ethernet, wireless LAN. And it does frame forwarding transparently. However, it needs to run a spanning tree to eliminate loops. And usually, bridging usually on the switch, layer 2 switch or layer 2 bridge, it's all the port number would form. If it's a 24 port Ethernet switch or 84 port, all the ports together will form a broadcast domain naturally. However, you might want to configure several ports to form a broadcast domain. So you probably want to configure half of the switch, half of the port number of the ports in the switch, and the other half of the port number in another switch to form a broadcast domain. Then you need VLAN to do the job. So VLAN, you can consider VLAN as an artificial way to form a broadcast domain. An artificial way to form a broadcast domain. And we have seen a device driver implementation, and three basic mechanisms are I/O port probing, interrupt, and DMA. And the concept of how a device driver works will probably be very useful in your later career, because if you are a developer, there's a lot of demand of device driver programmers in the industry. In the industry, they need a lot of driver developers for all kind of devices. Not here today. We just talk about the network driver, the say Ethernet driver or wireless LAN driver, but there are all kind of driver needed. Say USB devices, then you need many driver developers, and for WiMAX or LTE interfaces, you also need drivers. For very many kind of codec, video external codec, you need driver developers too. So the concept of how a driver works and how to program a driver is important. And I hope that this section will be helpful for your later career. Okay, and the links are still evolving, especially on Ethernet and wireless LAN. We are still evolving. For Ethernet, it's you have seen in the market. You have seen we could see product of 40 gigabit per second and 100 gigabit per second interfaces. Perhaps just several years ago, you have the highest capability is 10 gigabit links, but now you have 40 giga or 100 giga links. However, on wireless LAN, it's still below. It's still at a range of megabit per second. 11N is targeting at 600 megabit per second, but but in the field, for example, in the lab, it probably could reach 600 megabit per second in a perfect environment. Okay, in a perfect environment, it would no interference, and the signal strength, the signal to noise ratio is high. In a very perfect environment, 600 megabit per second could be achieved. But that could degrade to 100 megabit per second or less in the real environment, because the real environments are full of noise, degradation, all these kind of interferences. So we are still, the bandwidth is still not that abundant on wireless LAN, especially when those say 100 or several hundred megabit per second are shared by, is a broadcast link. It's still a broadcast link shared by stations, by many stations together. So each station will be able to grab a certain time. I can transmit at 100 megabit per second for some of the time, but not all of the time. I need to share the bandwidth with all the other stations. So when I get my share, I can transmit at hundreds of megabit per second, but I cannot share the link all the time. I cannot access the link all the time. I need to share the link with many others. But when I get my share, I transmit at megabit per second, hundreds of megabit per second. Okay.